In section 9.2 of our statistics OER course, we will do a hypothesis test for two population means when we know the population standard deviations. As a reference, in the Introductory Statistics by OpenStax textbook, this is section 10.2, two population means with known standard deviations, and in the Introduction to Statistics with Corequisite Lumen book, we are also in module 10 for hypothesis testing with two samples. So, similarly to when we have two population means but we don't know the standard deviations, the random variable that has to have a single value will be the difference of the two sample means. And provided that both populations are normal, the sampling distribution of the difference of the two sample means will follow a normal distribution with mean the difference of the two population means, and standard error or standard deviation the square root of sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. Since this is a normal distribution, the test statistic will be a z-score, and the z-score will be the observed difference of the sample means minus the mean of the distribution, which is the difference of the population means, divided by the standard error, which is the standard deviation of this distribution. So we want to try to solve some problems using this information, and based on the knowledge that we learned when we did two population means with unknown standard deviations. Here's an example. The mean lasting time of two competing floor waxes is to be compared. 20 floors are randomly assigned to test each wax. Both populations have a normal distribution. I want to remind you here that based on the story, N1 is equal to 20 and N2 is also equal to 20. This is not stated clearly, but we have to remember that. And the data are recording in the table below. Wax 1 had a sample mean number of months the floor wax lasted was for 3 months, and a population standard deviation of 0.33. And wax 2 had a sample mean number of months that the floor wax lasted of 2.9 months, and the population standard deviation was 0.36. Does the data indicate that wax 1 is more effective than wax 2? And we have a level of significance of 5%. Now, more effective would mean that the mean number of months that the floor wax lasts would be longer than the wax type that is less effective. The null hypothesis is always that there is no difference between the two variables, so the means are equal to each other, or as it pertains to the variable of the difference of the two means, the difference of the two means is equal to 0. The alternative hypothesis would be if wax 1 is more effective than wax 2, which means if the mean of wax 1 is greater than the mean of wax 2, or in terms of the random variable of the difference of those two means, if mean 1 minus mean 2 is a quantity that is greater than 0. The distribution, as we said, is going to be a normal distribution. We are talking about the variable x1 bar minus x2 bar. It follows a normal distribution. It will have a mean of the theoretical difference of those two means, which is 0, from the null hypothesis, that is the theoretical distribution, and a standard deviation of the square root of 0.33 squared divided by 20 plus 0.36 squared divided by 20. So I need a value for this, and I will either use my calculator or I'm going to use Excel. I have already started an Excel file. I have entered the data right here, and I'm going to find the standard deviation of the difference of the means. So equals the square root of this sigma squared divided by this n plus this, maybe I want 27, I guess, the 0.36 sigma, that sigma squared, divided by that n2. So this comes out to be 1092,016. So let's write this again. So this is a normal distribution with a 0 for a mean and 0.1092, and I believe it was 0.16. Yep. All right, 0.16. So when I sketch my normal distribution here, I will have 3 tick marks to the left and to the right of the mean. The mean is 0. This is the mean difference. So notice here what is our variable name is the difference of the sample means, and every tick mark will be 0.1092. Our point estimate is the difference of the two means that we found, so it will be actually the x1 bar minus the x2 bar, and that is equal to 3 minus 2.9 or 0.1. And I can also find it here, x1 bar minus x2 bar equals this 3 minus this mean 2.9. And then the test statistic will be this z-score, that is the difference that I found of the two means minus the theoretical difference of the means, which is 0, divided by the standard error that I calculated. So the test statistic will be a z-score that is equal to 0.1 minus 0 divided by the standard deviation, 0.1092,016. And again, I'm going to do that in my calculator or in Excel, not here. So equal to 0.1 minus the null hypothesis. Our hypothesis test assumes that the null difference is 0 divided by the standard deviation. And I get an answer to be approximately 0.9157371. And then I want to find the p-value and compare it to alpha. So for that, in Excel, I can use the normal function. First of all, let's sketch where is our point estimate. Our point estimate was here at 0.1. And the p-value is the area on the right tail after that. And we can find it in two ways. If this was a standard deviation, a standard normal distribution, it will have a mean of 0 and a standard deviation of 1. And then the test statistic of 0.9157371 would be used to find the area under the curve. And the other option would be if I was using the mean of 0 and the standard deviation of this complicated square root, then I could just use the normal distribution that is not standard to find the probability in the right tail. When I use Excel, Excel finds always the lower tail, so it would find this probability. So to find my p-value, I would have to subtract this probability from 1. So the p-value, which is the area in the right tail, will equal to 1 minus the probability that the difference is less than or equal to the 0.1. that I found. So when you use Excel, that would happen. Of course, you could have used, we could use Art of Stat, and I'm going to demonstrate in a minute after we use Excel to just find the probability of the right tail. So for now, let's use Excel. So when I use Excel, remember the Excel is going to give me the yellow area, the area to the left tail. So I need to make sure I subtract it from 1. So I can do 1 minus normal. Oh, let me put a 1 equal here so that it knows that I am trying. So normal distribution. You can select the normal distribution here. It says to you what is the x, and the x is this. And then what is the mean? Remember that the mean is the null value. So if you haven't entered it somewhere, then you will have to just enter it manually. In reality, we do want to ask the user to enter the null value of 0, just to ensure that that's the hypothesis we are testing. But for now, we will just add it ourselves. What is the standard deviation? Press comma, then standard deviation. The standard deviation is this value. And then, do you want it to be cumulative? Yes, I do want the CDF. And I don't know why it doesn't take it, but it's fine. I will just enter it here, true. And it's going to tell me that this is the p-value. I had another option. The other option would be to say 1 minus normal and use the standard normal distribution. When I use the standard normal distribution, it needs a z-score because it knows that the mean is 0 and the standard deviation is 1. And that now would have been my test statistic here. And do you want it to be cumulative? Yes, I do. So both answers should be the same because the test statistic is actually calculated from the mean and the standard deviation of the distribution. So I have a p-value of 0.1799. Which is much larger than alpha. It is almost 18%, where alpha was 5%. And therefore, the decision is that this difference is not unusual, coming from a theoretical distribution of a difference between the means being equal, which means that there is no difference between the two waxes. So the decision is that we fail to reject the null hypothesis. And the conclusion will be that at a 5% level of significance, the sample data did not provide sufficient evidence to support the alternative hypothesis that wax 1 is more effective than wax 2. So you can pause the video and write your conclusion and then compare your conclusion to the one that will be filled in here. So now we are going to try to do this hypothesis test in Art of Stat. Remember that Art of Stat does not have a normal distribution hypothesis test for means. So in the web apps, we want to go to the normal distribution and we want to enter the values that we found. So we found that the mean will be 0 and that the standard deviation will be 0.1092. Let's find a little more. Let's remind ourselves. 0.16. Okay, let me make this smaller so that I can see my numbers there. All right, 0.16. And then we wanted a right tail probability to the right of 0.1. And we found here that the probability is 17.99% or 0.1799, which agrees also to the with the p-value we found and what we wrote here when we rounded the p-value, and that p-value is greater than alpha, which results in the same decision and the same conclusion. Let's try to use Art of Stat to solve this problem. I also want to tell you that once I have coded the formulas here in Excel, I can just copy them over in my next problem and it's going to do the work for me. So we will have the opportunity to also just clone our work in Excel. But for now, let's try this using Art of Stat. The means of the number of revolutions per minute of two competing engines are to be compared. 30 engines are randomly assigned to be tested. Both populations have normal distribution. Again, you see here that N1 is 30 and the N2 is 30. I have written that as a note. And the table below shows the results. We had a sample mean number of RPMs for engine 1 at 1500 and for engine 2 at 1600. And the population standard deviation was 50 RPMs for engine 1 and 60 RPMs for engine 2. We need a 5% level of significance. And our null hypothesis will be that the difference between the two populations does not exist, so it is equal to 0. And the question that we want to check is whether engine 2 has a higher RPM than engine 1. So we want to know if M2 is greater than M1, which makes the difference M1 minus M2 be a negative quantity. And that will be our alternative hypothesis. The distribution is approximately normal. We are talking about the difference of the two sample means. It has a theoretical mean of 0 and a standard deviation the square root of 1 standard deviation squared divided by 30 plus the other standard deviation squared also divided by 30. And when I copied the formulas here in Excel, it said the 50 squared divided by 30 plus the 60 squared divided by 30. And that came out to be 14.26 approximately. And I'm going to enter them here so that I can see my graph. So the mean is 0 and the standard deviation is 14.2595. And you see here in the bottom the numbers that you want to enter for your axis in your graph. And also remember that the variable here is the difference of the two sample means. The point estimate is the difference between the two means, so it is negative 100. Remember, we are subtracting mu1 minus mu2 and x1 bar minus x2 bar. So your point estimate is x1 bar minus x2 bar. It is negative 100. This generates a test statistic that is negative 100 minus 0 divided by the 14.3 or 265 standard deviation. This comes out to be a negative 7. That is negative 100 divided by 14, approximately negative 7.013. That is a z-score, negative 7.013. And if you pay attention here, the negative 7.013 is a z-score. And a z-score or a negative 100 of a difference between the two sample means is really far to the left. It's going to be somewhere here. So this will be our z-score of -7. This will also be approximately where the x1 bar minus x2 bar difference of -100 lies. And if you try to use the normal distribution app to find the probability in the lower tail, and here you write the value of -100, you will see that it's really far away to the left. The probability here that your value, or the difference between the two means, will be -100 is very small, approximately 0. That's your p-value. It is approximately 0.0000. If you want to round it to 4 decimal places, it is very small compared to alpha, which means that having a difference of 100 RPMs, it is an extremely unusual situation or result coming from a theoretical distribution that implies that the two means are equal to each other and there is no difference between them. Therefore, this is a very unusual result. We have enough evidence to reject the null hypothesis, and our conclusion will say that at the 5% significance level, the sample data provide sufficient evidence to support the alternative hypothesis that engine 2 has a higher RPM than engine 1. Now, one thing we have to remember is that this is a left tail test, and the math that we copied here in Excel was above here was for a right tail test. So this math here assumed that we have to use the CDF for the normal distribution, but then subtract it from 1 in order to get the right tail. However, the p-value for this particular problem is the left tail, which is the normal CDF. So here we want to remove this 1 minus and just use the normal distribution CDF. And here we want again to remove the 1 minus and just use the normal distribution CDF. That will give us the area to the left tail. And you can see here that this is indeed approximately 1.17, and it's really far into the decimal place, 12 decimal locations, decimal places to the right of the decimal point, and that also is reflected here in this percentage value. So our calculations in Excel are correct and they agree to the art of stat. As a reminder, for this particular section 9.2, we have a hypothesis test that compares two means of two independent populations, and the null hypothesis will always be, for our course, that the difference between the two means is equal to 0.